Hello, welcome to On Wildlife. I'm your host, Alex Ray. On this podcast, we bring the wild to you. We take you on a journey into the life of a different animal every week, and I guarantee you're going to come out of here knowing more about your favorite animal than you did before. This episode's animal is extremely unique and one of the oldest animals on Earth. They don't have the best reputation because their stings can be dangerous to people, but I think you guys are really going to be amazed at all of their weird characteristics. So today, we might need to get into a submarine because we're headed into the ocean to talk about jellyfish. Jellyfish are found in all oceans across the world, and they're really adaptable. They can live in warm tropical waters as well as cold Arctic waters. And they can live at the surface or near the deepest depths of the ocean. Because there's so many different jellyfish species, the size and weight range drastically. The size of the bell, which is like the squishy part of the jellyfish, can range from 0.2 of an inch to over 6.5 feet. The smallest species of jellyfish is the Irukandji jellyfish. It can only get up to about a few centimeters, but it's actually the world's most venomous jellyfish. And different species' weight varies drastically too. Some jellyfish can weigh under an ounce, while others can weigh up to 440 pounds. One of the larger jellyfish species, the lion's mane jellyfish, can be up to 6.5 feet long and weigh around 200 pounds. That's almost as big as LeBron James. Jellyfish are in the phylum Cnidaria, which also includes anemones, corals, and sea whips, and was named after the Greek word for sea nettle. The main thing Cnidaria have in common is their radial symmetry. This means that their body parts radiate from the central point of their body. This is really helpful for jellyfish because it allows them to detect food and respond to danger in any direction. The phylum Cnidaria are among the oldest animals on Earth, with their fossil record going back at least 500 million years, but it could be as old as 700 million years. This is 3 times older than the dinosaurs. And since jellyfish have no bones and are made out of water, they don't leave any fossils, so it's hard to say for sure how old they are. Something that they're probably known best for is their sting, and we're going to get into why and how they sting later on in the episode. But I know what you're thinking. Does peeing on a jellyfish sting really help relieve the pain? And the answer is no. It's not helpful at all, and it can actually make it worse by releasing more of the venom into your body. Some jellyfish are carnivores, and they eat small fish and zooplankton by capturing their prey in their tentacles. And they can actually control where they're swimming, but they're really slow swimmers, so they move rhythmically by opening and closing their body, and they force their prey within their reach. Once they reach the tentacles, they have these things called cnidocytes that inject venom into their prey. Cnidocytes are so cool and they're extremely specialized. They're basically loaded like a spring. And when they sense the chemicals that the prey gives off, cnidocytes shoot out what looks like a harpoon that sticks into the victim. And the harpoon has venom inside of it. Not only do they do this to their prey, but they also use it as a defense mechanism against predators, including us. This is what makes jellyfish stings so painful. These toxins can paralyze or kill their prey, and then the jellyfish can pull them into their mouth. For humans, the stings are usually not that severe, although they do vary between species. There are a few jellyfish that are highly dangerous to people, like some species of the box jellyfish, which can be found in the Atlantic and Pacific Oceans as well as the Mediterranean Sea. In the Philippines, box jellyfish kill over 20 people every year. But not all jellyfish are carnivores. Other species have a symbiotic relationship with an algae called zooxanthellae. The algae lives in their cavities and provides jellyfish with enough carbohydrates by doing photosynthesis that they don't need other sources of food. An example of this is the upside-down jellyfish, and just like the name suggests, they lie upside down in shallow waters so that their tentacles, which is where the zooxanthellae live, have access to sunlight. There are also other jellyfish species that don't have tentacles. They have 8 oral arms, And these oral arms basically help the jellyfish take food in and bring it towards the mouth. But some species don't even have a mouth. They have a small mouth-like opening on each of their oral arms. So just imagine if your arms had a mouth on them. That's cool and all, but what are jellyfish actually made out of? You're going to hear more about that after the break. On this episode of Notable Figures in Science, I want to recognize Alice Ball, who was an American chemist in the early 1900s. She was the first woman to get her master's degree and become a professor at the University of Hawaii. Her parents worked with chemicals in order to develop photographs, which may have sparked her passion for chemistry. After she got her master's degree, she worked with another scientist on trying to figure out a cure for leprosy. At that time, it was untreatable, and people who had it were sent to a secluded island to die. But she figured out a way to inject a specific type of oil into people's bodies that cured the disease. This was later called the Ball method. Unfortunately, she passed away at 24 due to unknown causes, and after her death, another chemist stole her work, claiming that it was his. She finally got the credit that she deserved when he came clean years after her death. If you want to learn more about Alice Ball or this series, check out onwildlife.org. Okay, we're back. In the water, jellyfish are majestic, beautiful creatures floating in the sea. But when you take them out of the water, they become kind of like a blob. Why does this happen? Jellyfish are simple. They're 95% water, which means only 5% of jellyfish is solid matter. And they don't have a brain, a heart, or blood. And you probably already knew this because they're usually see-through. And their body has 3 different layers: the outer layer, middle layer, and inner layer. The outer layer is called the epidermis, which contains the nerve net, which is basically just a bunch of nerves clumped together. The nerve net acts like a brain because it controls their movement and other bodily functions. It also helps them with their senses. And even though they don't have a nose, they can smell by picking up on different chemicals in the water. And they can also detect light, even though they don't have any eyes. The middle layer is the thick jelly-like stuff called the mesoglia. And the inner layer is the digestive cavity called the gastrodermis. The digestive system of a jellyfish is really simple, just like they are. The cavity is both the stomach and the intestine, and they have one opening for the mouth and the anus, so everything that goes in comes out of the same place. Now, we talked about how jellyfish are kind of simple, but not when it comes to their life cycle. Jellyfish babies begin as eggs, which then grow into small larvae called planula. During this stage, they're microscopic and they look like flatworms. There are little hairs covering the planula called cilia that help them move through the ocean. And in this stage, the planula is growing and growing, and once it's big enough, it finds a solid surface to attach itself to, which leads us to the next stage. This is where they become polyps, and polyps are like the adolescent phase where they're attached to the ground. During this phase, they have a ring of tentacles extending outward that surround the mouth, and this is how they catch their prey. Depending on the species, jellyfish can remain in this stage for multiple years. Eventually, the polyp elongates and forms segments that will break off and become new individuals, and this is called strobilation. The segments of the polyp that break off become the ephyra, the final stage before the full adult jellyfish. The ephyra is really small, but it grows quickly. And it doesn't have the bell shape or stinging tentacles like the adult does. And remember that this is only a segment of the polyp, so while the ephyra is growing, the polyp is still making new segments. The final stage of the jellyfish life cycle is the adult, called the medusa, and this is the jellyfish that you actually see in pictures. One of the coolest things about the jellyfish life cycle is that some species can actually reverse it. They can go from their adult stage back to a polyp, and this basically makes them immortal. And just like chocolate chip cookies and X-rays, jellyfish immortality was discovered by accident. In 1988, a marine biology student named Christian Sommer was collecting data on hundreds of different types of invertebrates. One of the species was Turritopsis dohrnii, a type of jellyfish. As Sommer prepared to go home, he forgot to place the bowl with the jellyfish in the refrigerator for the weekend. When Sommer returned to the lab, The adult jellyfish were seemingly replaced by a juvenile. But he knew that this particular jellyfish had a longer reproductive cycle, so the adult couldn't have reproduced in that time. And after seeing this phenomenon happen multiple times, he came to the revelation that this jellyfish could reverse its life cycle. Jellyfish can still die from disease and predators, and in fact, they die kind of easily. The most common cause for them reversing their life cycles is stress, and the way that this works is that the medusa, or the adult jellyfish, is able to go through a process called transdifferentiation, where it can change its cells into different types of cells. Because of this incredible stress response, the immortal jellyfish is found practically all over the world. And while it's extremely unlikely that humans will ever be able to become immortal by using this technique, we can gain a lot from the study of how jellyfish are able to do this, and it can even help us find a cure for cancer. And if you thought their life cycle was cool, just wait until you hear about this adaptation that I'm going to talk about, right after the break. It's time for our trivia question. Which planet has the most moons in the solar system? A. Mercury, B. Venus, C. Saturn, or D. Neptune? The answer is C. Saturn has 53 different moons. Okay, we're back. Remember earlier when I was talking about how jellyfish can be found really deep in the ocean? Well, the further down you go, the less sunlight you have. And sometimes this means that you have to produce your own light in order to survive. Some deep sea jellyfish are able to do just that. They use chemical reactions in their body to basically glow in the dark, and this process is called bioluminescence. They get these chemicals from different things in their diet. Bioluminescence can be used for a bunch of different purposes depending on the species, but for jellyfish, it's used mainly as a way to defend against predators. A bright light can easily startle or confuse a predator, which could be enough to scare it off before it eats the jellyfish. But what if a deep-sea jellyfish wanted to come near the surface? Well, many different types of ocean creatures migrate at some point every year, and some jellyfish do migrate, but in a different way than usual. They practice vertical migration, where they arise to the surface in the ocean in large masses, which is known as blooms, and typically occurs in the spring. But again, due to the wide variety of jellyfish, it's impossible to generalize. Some jellyfish migrate once or twice a day. Other species migrate horizontally by following the sun. And jellyfish are a prey for a lot of different animals like sea turtles, crabs, fish, and dolphins, which makes them really important for the ocean ecosystems. This can be an issue though because of plastic pollution. If you've ever seen a jellyfish, you could kind of tell they look like a plastic bag. Well, what happens is animals like sea turtles will see a plastic bag and eat that, thinking it's a jellyfish. And this is devastating to their digestive system. Now, something that you might not think about that puts plastic into the oceans is your phone case. And this is why I love Pella cases. They're 100% compostable, and they're so much better for the environment than any other plastic phone case. And they also have really cool designs on them. And not only that, but they donate a portion of their sales to ocean cleanup initiatives. I absolutely recommend buying one, and if you do, you should use the link in the description of this episode or on onwildlife.org. Not only does using Pella cases help the environment, but it also supports the podcast with every purchase using the link. Okay, back to jellyfish. They also have symbiotic relationships with other species like zooantheli that rely on them for survival. And on top of all that, species like sea anemones, brittle stars, gooseneck barnacles, lobster larvae, and fish like to hitch rides on jellyfish because they provide safety from predators. And dolphins actually use some species of jellyfish like underwater frisbees. They know that if they avoid the stingers, jellyfish are harmless, and they've even been seen to fling jellyfish out of the water to play with them. And normally on this podcast, we talk about species that are threatened, but jellyfish are actually in overabundance. Their populations are rapidly increasing, which is an indication that there are some serious issues going on. Unlike a lot of other species, Jellyfish can live in damaged ecosystems because of their resilience, and overfishing and the death of other predators like sea turtles have caused them to become unregulated. This is becoming a major problem because jellyfish like to eat fish larvae, meaning that they're making it harder and harder for fish populations to recover. They've become so abundant that scientists are actually researching ways that we can use jellyfish for food and even to generate power. Because jellyfish aren't endangered, here are some organizations that are working to help educate people about the issues that the ocean is facing. Take a look at the Jellyfish Project, the Coral Reef Alliance, and Project Aware. Thank you so much for coming on this adventure with me as we explored the world of jellyfish. You can find the sources that we used for this podcast and links to organizations that we reference at onwildlife.org. You can also email us with any questions at onwildlife.podcast@gmail.com. You can also follow us on TikTok at onwildlife and Instagram at on_wildlife. Don't forget to tune in next Wednesday for another awesome episode. And that's On Wildlife.
You've been listening to On Wildlife with Alex Ray, brought to you every Wednesday.